Okay, grade 10. Let's talk about the difference between physical and chemical change. This topic is called chemical change, and it leads into chemical reactions, and then it leads into calculations based on chemical reactions. So we've already talked about physical changes, like for instance, you can see my glass of water here, and my glass of water's got all this ice in it, and then the ice is changing state. And we've already discussed this. We know that this is a physical change. Over here, we have something that is on fire. This is potassium dichromate or ammonium dichromate, and it has a strongly exothermic reaction, which means it gets really, really hot and makes a fire. So how do we know that this weird thing over here changing and this weird thing over here also changing? How do we know which one's a physical and chemical change? And so this is sometimes not as obvious as it seems, which is why we have to discuss it. Okay, so a physical change will occur with no change in composition. Okay, so when I say change in composition, I'm talking about the chemistry of the things that we've got here. This glass of water is H2O, water. It will dissolve, and I'm left with H2O, water. It's just changed state. So things that can describe a physical change. The composition is not changing, so H2O, 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 always H2O. We can change state, for instance, solid, liquid, gas, gas, liquid, solid in either direction. You can change shape. You can see the ice is clearly changing shape. And sometimes there's a color change, okay? So these are things that can tell you a physical change is occurring. One of the main things as well about physical changes is you only need a small amount of energy. Because for instance here, when this ice is changing state, the thing that's making it ice is the intermolecular forces, and you don't need a lot of energy to overcome intermolecular forces or electrostatic forces. So that's what happens with a physical change. And a physical change is often or usually reversible. If I want to turn this water back into ice, I just have to go and lower its temperature, which is actually, when we talk about amount of energy, it's a relatively small amount of energy to change state. So the thing you have to bear in mind here, during a state change, solid to liquid to gas to solid and all the way around in all the directions, during this state change, the composition of the substances is exactly the same when the phase changes. If this is iodine, then this is iodine, and this is iodine. If this is water, this is water, this is water. We are having no changes in the chemical composition. So it is literally just what we started with, and the intermolecular forces have changed. We haven't suddenly magically got some other compound, okay? So what happens during state change? What is going to stay constant or not change? The size of the particles and the mass of the particles. If I put, for instance, a whole lot of water vapor in a balloon, and I weigh the balloon and it's full of water in the gas phase, and then I let the balloon cool down, you'll see that the water, steam, the water in the gas becomes water liquid, but the balloon is not going to change its mass, okay? So as well, all of those little H2O particles are not going to change their mass. They're still going to be H2O, they're not going to change their mass. The shape of the particles is not going to change. When we say the shape of the particles, we use this word particles a lot because we can't always talk about, for instance, atoms or molecules. We can't use chemistry specific words because this is a general phenomenon. So when we talk about them, we use the word particles a lot, and these particles just means atoms or molecules or whatever it happens to be in the substance that you're talking about. So the shape of the particles is not going to change. That little water molecule is still going to be that little bent water molecule that I always show you diagrams of. So those particles are not going to change shape. Yes, your ice might change shape, so the substance might change shape as the ice goes to water, but the little H2O particles will remain as H2O particles. And if I started out with 100 water molecules, I will end with 100 water molecules. So these remain constant during a physical change, okay? So here is a good example of what I'm talking about. When you change the shape in a physical change, the chemical composition remains the same, but the shape changes. So for instance, here is a piece of metal that somebody on Forged in Fire is turning into a horseshoe, and you can see they'll hit it with a hammer and this straight piece of metal becomes a bent horseshoe. You might notice it's also changed color when we heated it. The other example is if you buy coarse salt and then your coarse salt won't come out your salt shaker, you can put it in this object which is called a pestle and mortar, and you can grind it up into fine salt. So if this is salt, it was sodium chloride before you started, it was sodium chloride after you finished. You've not changed anything about the chemical composition, just its shape. The same thing here with the color change in a physical change. If this was iron, this is still iron. It hasn't suddenly become gold just because it's a shiny gold color. This color change is temporary, and it absolutely does not affect the elements in here. Another example of this is your stove plate. When it gets hot, it gets all red, and then you turn your stove off and it goes back to that funny black color. So the color change, when the color changes, it's temporary and the chemical composition is remaining the same. So the other way is if you know something's a physical change, like for instance here's a mixture in this container over here, and how do we know that this is one chemical or more than one chemical, or is this a mixture or a chemical reaction? How do we know what? You can separate mixtures quite easily by distillation, this process distillation. So if we boil this, the two things will have different boiling points, and I will easily separate out, for instance, the alcohol from the water or something like that. So as you boil this, the thing with the lower melting point boils off first, and it goes up this tube where it's cooled, and then you collect it down the other end of this condenser tube. So this, for instance, is an easy method with a low energy input to separate mixtures by physical means. Okay, so I'm going to stop here, and in the next video we'll start with chemical change. But what the main takeaway part of this is, if we look at all of these changes, we are not changing the size and mass of the particles, we are not changing the shape of the particles, we are not changing the number of the particles, and basically everything is reversible. We don't change the chemistry, nothing like that. Everything is temporary and reversible, and not a lot of energy is required to carry out this change. Okay, and we will stop here.